Hi everyone, here we are discussing the maximum flow network which is going to be used in the transportation network. So, road transport is established with multiple lanes in the highway. Then, here which is allowing multiple vehicles in that lanes parallelly. So, for example, here three lanes highway is constructed, then three vehicles can be allowed at a time. That means capacity is here 3, right? So in this capacity of 3 at a time, there is the possibility of two vehicles may be coming at the time, right? Or one vehicle may be coming at the time. So three vehicles also allowing at the same time. Okay, the maximum capacity is 3, but the vehicles which are coming at the same time can be allowed one vehicle or two vehicle or three vehicle. After reaching some junction, there is the possibility of only two lanes here. So capacity is here 2. So maximum capacity is 2, but the vehicle at a time can be driven here 1 or 2. So like that, based upon this scenario, we can establish the network. Here multiple junctions are there: A, B, C, D, and source is this one, and destination is the place which is going to be reaching by the passenger, right? So here S2A, which is allowing maximum capacity of the lanes 3, so three vehicles at a time can be driven between these two places. And A to B, the capacity is 2 lanes, right? Then B to T, here capacity is 3 units. Like that, here for all the places we are using the edge with respect to capacity value. Here our aim is identifying the maximum number of vehicles can be driven from the source to destination by using this capacity of the highway, right? So here maximum vehicles at a time can be driven 2. Here maximum vehicles can be driven 3, right? But here you see maximum vehicles can be received from the B3, and maximum vehicles can be received from the D2. Like that, B to C, in this route we can drive only one vehicle at the time, because this is single lane road, right? So like that, we have to identify the maximum flow from the source and the destination. Initially I am taking the S2A. Here maximum capacity is 3, but here I have to use the 3 constraints. One is the capacity constraint, and the second one is skew symmetry constraint, and the third one is flow conservation. So flow conservation can be calculated for all the vertices except the source and destination. So here I am applying that capacity constraint. So capacity is here 3. My flow as of the initial iteration, I am considering only 1 unit. So 1 unit can be passed. So F is less than or equal to capacity between the U comma V. So here S is the U, and V is the A. Then next I have to check the incoming flow should be should be less than or equal to outgoing flow. So here, as of now, in the vertex number A, so there is no flow, right? Only flow we have used S to A. Then I am taking the route from A to B. Here the capacity is 2. Then I am checking the flow. So flow value is as of now 1. So 1 less than or equal to 2. So which is allowing the flow. Then I am taking B to C, right? So in this B to C, capacity is 1. Then flow is here I am passing 1. So 1 is less than or equal to 1. Then which is also allowing this flow. Then C to D, I am taking this path. Here my incoming flow is 1. So 1 is less than or equal to 2. Yes, which is true. So we can allow this flow from the C to D. Then I am taking a D to T. Here my flow is here 1. right? This 1 is less than or equal to capacity 2, so which is also true, right? So 1 less than or equal to capacity 2, right? Then we can allow this flow into the next vertex t. So now I reached the destination. So in this path, right, s to a to b to c to d to t, which is allowing the flow value 1. And here in the b, you may think, why do we take B to C? I can take B to T, right? Yes, you can consider this path also. In my perspective, I am using this B to C, C to D, D to T. If you want to use directly B to T, you can use that. That is also valuable path only, right? And the next one is, in the next iteration, identifying the next flow is that possible in this route, in this network. So now I am taking this path s to c, right? So already this path is constructed in the previous iteration. Now I am going to construct the next path in the second iteration. So by considering s to c, right? So s to c capacity is 2, my assuming flow is 1, so flow less than or equal to capacity, which is true, then I can consider this path. Then after that I am taking c to a, right? So here capacity is 3, my flow is 1, so 1 less than or equal to 3, which is also allowing. So now the flow here 1, here 1, so 1 plus 1, 2 flow is coming, right, into the a, right? So here we have to check, right, that incoming flow should be equal to outgoing flow. So here outgoing flow, already we have received only 1 unit from this path. Now we are adding this one more unit in the existing flow, so 1 plus 1 we are getting 2. And in that, when you are adding that, you have to check f less than or equal to capacity. So here capacity is 2, flow also 2, which is also allowed, right? Then I can consider the b vertex here. When it is coming that 2 units of the flow, already 1 unit is used in this path, then I cannot use this again because the capacity is 1. So another outgoing path is b to t. So here I am checking the capacity constraint. So 3 is the capacity, my outgoing flow here, new flow 1 unit, so 1 less than or equal to 3, which is true, then I am allowing this flow. So I now reached the destination t. So in the second path again, s to c, c to a to b, b to t. So s to c 1 unit, c to a is also 1 unit. Here in all the edges we are allowing only one flow, so that is the flow cost here 1. So now in the previous iteration I got flow value is 1, and this second iteration also I got flow value is 1, so totally my flow value is 2. Again I have to check the next possible flow in the next iteration, third iteration. I am trying to identify new flow. Is there any possibility? So this is the structure we got from the previous slide. Now third iteration, I am checking the next path S to C. Earlier the flow value is 1. Now I am adding one more flow, 1, right? So 1 plus 1 2, and after adding that we have to check the capacity also 2, so which is true, then I am allowing this path. After that I am taking the new path c to d. Already c to d is flow 1. Now I am adding one more flow, new flow in the third iteration, that 1 plus new I mean existing flow is 1, so totally 2. Then 2 less than or equal to capacity 2, which is also allowing, so then we can allow this flow to the d. After reaching the d, here I am taking the path this one. Already there is no flow, that means 0/3, right? So here I am allowing the new flow, that is having the value 1 less than or equal to 3. Yes, it is true, then I am allowing this. After reaching the b, here you see the b is receiving here 2 units, and here right, so here newly we are receiving 1 unit, so totally we are receiving 3 units. Outgoing here is 1 unit, and here 1 unit, so only 2 units. So now we have to identify the path for this new flow 1. So in here again there is the possibility of the value. So here capacity is 3 but already used flow is 1, so I can add the new flow 1 into the existing flow here. So 1 plus 1, here I am getting the 2, so 2 less than or equal to 3. Yes, it is true, then I can use this path to pass the new flow. So now I am reaching the T. So using this new path, S2C is 1, C2D is 1, D2B is here 1, and B2T is also 1 unit. So total cost is here I am receiving in the third iteration, all right, for this particular iteration 1. So total flow here in the third iteration, first iteration 1, second iteration 1, third iteration 1. So now I have received total flow is 3 units. After this again I have to check is there any more path possible, right? So here for checking that possibility, here you check here, this one, when you are checking you can increase or decrease the flow in the edges, right, by using the flow conservation. So here you look at that, in the flow conservation we have to calculate incoming here 2 units, outgoing here 2 units, okay, which is here 2 units, but here incoming 2 and here also 2, so 2 plus 1 3, here 2 units consumed, here 1 unit consumed, so it is equivalent. So based upon that we have to check is there any other new path possible. So here by increasing or decreasing the flow in the vertices, right, by based upon the flow conservation property, we can check the new path. So there is the new path available between the C2A, right? So here you look at that, here C2A I am decreasing this into the 0, so that's what I'm doing here. If I decreasing this 0, then you see the flow conservation is not matching. You look at that, here 2 units I am receiving, here 1 unit I am receiving, but outgoing is here only 2 units, so I have to make this change, right, one more change. So for that here I am making the flow to A is 1, okay, so outflow is here 2, right? So you look at that, here incoming flow is 1 but here outgoing flow is 2, so I have to increase here one flow. So now I am increasing 1 here between the S2A. After that I am checking here, S2 is incoming and outgoing also 2, right? So here 2 is incoming and C here, but 3 is incoming, okay, 3 is incoming, so I have to change this. So here flow conservation is not satisfied in the place of C and in the place of B. So here from the B, here 2 units incoming but outgoing is 3, right? That's what we have to change here. So for that we have to update B to C, right? B to C is I am updating from the 1 to 0 by decreasing 1 unit, right? Then D to B, D to B, here already we are having 1 unit, so I am decreasing that into 0, right? After decreasing that I have to check this, right? Incoming 2 units here, right? This 2 here 0, so 2 plus 0 2. Then outgoing here 0, here 2. So this is satisfied, right? Then now we have to check the another value here, D to T. Here incoming is 2 but outgoing is here only 1, so we have to increase that value as 2, right? That's what I have given in this next point. So totally now I got flow conservation is satisfied and capacity also satisfied, skew symmetry also satisfied. So based upon this, here you see my flow is maximized into 4. So you look at that, this path is allowing 2 units, okay, so 2 plus, and this path which is allowing 2 units, right? So totally I got 4 units of this one, but previously you see we got only flow value is 3 in the 3 iterations, but after updation by increment and decrement of the flow value between the vertices. Now I maximized the flow. So totally you check this, outgoing from the source is 4 and receiving to the destination is also 4, so it should be equivalent. So here if the network is having less number of edges, then it is easy to increment or decrement. Suppose if I am having the 10,000 number of routes or edges in the road infrastructure, then which is difficult to solve this solve this problem by using generalized method. So we have to use residual network to overcome this challenge by using the Ford Fulkerson algorithm. Thanks for watching.